Thanks for pointing that out, Zach. And we'll have a look now at our first example of using Kirchhoff. So do you remember you had two laws? What were the two laws? First one? Junction and loop, yeah. And I gave you some tips. Alright, so we've done this one already. Remember this one? Remember doing this one? But let's use Kirchhoff now. So on the top is 1 ohm, 2, 3, 4, 5 volts. Okay? So we start off here with a current, I1. And then the current splits here, I2 and I3, and still I2, and then still I3, and then it comes back together, back to I1 here. Okay? Let's use Kirchhoff's laws. So, if you look at this, you can see that there are three unknowns. So I must have to make three equations. The first one is the junction rule here. So what does the junction rule say? Yeah, sum of the current is 0. So what's the first equation I can make? It'll be I1 minus I2 minus I3 equals 0. That's our first equation. Is that okay? Are you happy with that so far? Yeah? Next, we'll make a loop. So we'll start at the 5 and we'll go down. Yeah? So you have 5. Are you all looking, guys? Look. 5. And then we have to minus the voltage here. What's the voltage here? Well, the voltage equals IR. V equals IR. So here it'll be minus 3 I2. And then here? Minus 4 I2 equals 0. That's our second equation. And finally, a loop up the top. 5 minus 2i3 minus i3 equals 0. What happened to you, Diego?
Shopping.
Oh, Diego, this is starting to become a habit, so much so that I think you actually need to be getting the earlier bus.
That's also true, yeah.
Yeah. Okay. This equation can give me I3. I get I3 is 1.67. It's 5 over 3. Yeah, 1.67, isn't it? Amps. And this one here can give me I2, which would be 5 over 7. 5 over 7? What's that, 0.6? 0.71. And I1 I can get from the first equation. Yeah. 2.38?
Yeah.
Now I think those answers match what we got last time.
Using B equals.
Using a lot longer process. Are you checking, Jordan, the last time we did it? Yeah. It was under simple circuits. I think we got the voltages as well. So we'll get the voltage at the same time. The voltage through the first resistor, V equals IR, so that's I 3. That's I3, 1.67. The voltage through resistor 2 is IR, which will be 2 times this. What is it?
3.34.
Okay, voltage 3 will be IR 3 times I2,
2.13.
and then V4 is 4 times I2. Nice. Okay, look, so the 3 currents and the 4 voltages, I have everything. Does this match up what we got? Yeah. Much easier to do, isn't it?
Yeah.
And they both add up to V1 and V2 add to 5, and V3 and V4 add to 5. Got that? Yeah. Yeah. Continue. Okay. So we're going to do this one together. So I'll start over with you, Dorian. We have here a circuit. I1 goes this way, I2 goes this way, and down the middle is I3. That's 4, 4, 16 ohms. That's a 12 volt and a 6 volt. And I want you to use the junction rule at B, and B is up here. So are we all looking? The junction rule at B, what equation could I make if I use the junction rule at B? And you have I1, I2, I3, yeah? Yep.
Plus I2
Yep.
minus I3.
Equal?
0.
Good. So can you all write that down as for part A? I1 plus I2 minus I3 equals 0. Okay? You got that? Yeah? Gina, can you use the junction rule at E, if you can see that? It's quite small. That's I3 going down, that's I1 going left, that's I2 going right. Yeah. You can come closer. Come here and tell us. Alright, so what's happening here?
At E.
Yeah, at E. Junction rule at E.
I'm not sure.
Tell me what current is going into E. It's I,
I3.
and what's coming out of E. It's kind of hard to see, but this way is I1, and this way is I2. So what's coming out?
Oh, so it's positive.
Yeah,
So it's I3 minus I1 is
perfect. Equals?
0.
Good, good. So can you write that down for the second one? I3 minus I1 minus I2 equals 0. Yeah? Lynn, what have you noticed about these two equations? Or maybe you didn't notice anything. If you look at the two equations, do you notice anything about them?
So I1 plus I2 equals I. No, it's not equals.
You might be thinking too much about it. What's the first equation?
I1 plus I2 minus I3 equals 0.
Good. And what's the second equation?
I3 minus I1 minus I2 equals 0.
Anything similar about them?
I know they are all equals to 0.
That is one thing similar. Something else even more similar.
We got the same.
Even more similar. Can anybody see?
It's just the same.
There's actually the same equation.
Sign is just changed.
It's just the sign has changed. How do you make equation 2 from equation 1? Just flip the signs. Yeah. Sorry, Lynn, that's what I was suggesting here. So, do you need both equations? No, you just need one of them. Okay. Harry, you get to make a loop now. And I want you to make the loop at A, B, E, F. A, B, E, F. So, where will we start in this loop? Wait, were you in the last class? Or were you off in...
Just
Car-
the S introduction.
Yeah, were you in the last class?
Yeah.
Yeah, okay. So, where do we start in the loop? Do we start at the 12, the 4, or the 16? Sorry, not the 4. Not the 16. You don't remember my tips from last week? You remember? What was my tip? Start at the battery. Start at the battery. So, if you can write this down, you start at 12. You write down 12. Then, when you get here, is it a plus or is it a minus?
Minus.
Minus what? The voltage here. What's the voltage here?
4 times
4I1. And here? Minus?
16 times I2.
Ooh, that's an I3 actually here. I3 equals 0. Good job, Harry. Alright, you all got that? Yeah? Alright. Zach, can you give me the loop for C, B, E, D, which is the loop on the right?
6 volts
6, yeah.
minus 4 I2
Minus 4I2
minus 16 I3
minus 16I3
equals 0.
equals 0. There we go. Right. Diego, give me the loop around the entire outside. Start where?
12.
Start 12. Okay, go.
12.
Yep.
Plus.
No. 12.
Oh no, I was gonna go. Yeah, no.
Oh, you're going down.
Yeah.
No. Go with the flow. Go with the flow. 12.
12 minus
Yep.
4 times I1.
Yeah, minus 4I1.
Minus 4 I2.
No.
Oh no, because you have changed the shape. Plus.
Plus 4I2 because it's
I2.
backwards.
Yeah, and then it's minus 6.
Good man.
Yeah.
Equals 0.
True, because you changed. Yeah.
Okay, you got Diego's one? Lastly, I'll answer it. Which three equations would we use? Well, we should use one of the junction ones. It doesn't matter which one. And we need to use how many more? Two more loops. I think I would use this loop and this loop. Because in both cases you could easily cancel I3. Anyways, we'll look at an exam question now. Can I continue? Gina? Yeah? Okay. So this was an exam question in section B of the exam. They ask you to find I1, I2, I3, but it's not really important. I mean, I could delete these questions and just give you this picture and say solve. The order doesn't really matter, okay? If you find I2 first, then fine, you found I2 first. I don't care. So, before we even begin, we can simplify this picture a little bit. How can we simplify it a little bit?
You got unify
Yeah.
both the resistors.
Yeah, which ones now?
The ones on the left and the ones on the right.
Yeah, the 5 and the 10, there's no, I mean, it's pointless having them like this. We might as well just make it a 15. It doesn't change anything, right? And it's pointless having it like this. We can make it a 5. So I want you to draw this, but I want you to draw this as a single resistor of 15 up here and a 5 up here. Okay? Then we'll have a look at it now. You got it drawn? Let me draw two. So, what do you say? There's one here. How much is that one?
15.
The one up here is 15 ohms.
No one is 5.
Which the neighbor is 5. And then the middle here is 4. And then what do you have here? You have a 4 volt, a 50 volt, and that's it. And let's put in our currents. Down the middle here is an I3, and then it splits to, on the left going around, on the left is an I1, and then going around this way, they have the arrow pointing left, so that would be going up here, I2. Okay, are you all ready to see this exam one now? Okay, before I start, I really like Kirchhoff exam questions. They're mathematical and they're possible to get full marks if you take your time and be careful. But I find students usually don't like it. I'm not sure why. But I didn't like these at first, but now I do. Because they're really just a maths problem. Alright, watch. Let's start with the junction here. I get I3 in minus I1 minus I2 equals 0. Let's make a loop at 50. Okay? 50 up minus 15 I1 minus 4 I3 equals 0. Correct? And then lastly, starting at the 4, 4 minus 5 I2 minus 4 I3 equals 0. Now, here's my, can I scroll down a little? Here's my tip for how you solve these, okay? You always delete the I that's in the 3 equations. Do you see any I that's in all 3 of them? I3 is the only one. So what we'll do is we'll multiply this by 4. Okay, so I'll just clean this up a little bit. I have minus 4i1 minus 4i2 plus 4i3 equals 0. Here I have minus 15i1 minus 4i3 equals minus 50. And here I have minus 5i2 minus 4i3 equal minus 4. Okay? Now I don't like all these minuses, so I'll just go plus, 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 plus.
What's your mark?
I'm minus now, yeah. Okay, next step. I take these two and I minus them. That's minus 19i1 minus 4i2 equals minus 50. Then I do the same for these two. 15i1 minus, is that i1 or i2? But I wrote a 1, yeah. Minus 5i2 equals 46.
46.
50 minus 4.
So 40. Yeah.
I'm okay?
Yeah.
I'm okay. Now, these two equations, what would be the easiest thing to do? I think we could multiply this by 5 and multiply this by 4. Yeah? Oh, what's that? 85? No. Yeah, no.
Yes.
Yes, 85.
85.
Minus 85i1
Yes.
minus 20i2 equals minus 250, is that correct?
Yeah.
60i1 minus 20i2 equals 200, no, 95, thank you, not 85. I knew something was a bit fishy there. 46 times 4, 80, 160, 172? 172? No, what am I saying? That's too small. 100, and now let me do this, I can do this. 188? Is it?
Minus 4.
Oh my goodness. Hang on,
184.
184.
Yes.
Okay, there we go. Right. Minusing again. Minus,
35.
well, this is minus 60, so that's minus 155. I1 equals minus 434. Minus 250 minus 184.
Minus 434.
Yeah. Now, while you have 434 on the calculator, can you divide by 155?
2.8.
Great. So I1 is 2.8 amps. Now, how do we get I2? We can just sub it into that one. So I wonder if you could do that on the calculator. It'd be 184 minus 60 times 2.8, and then divide the answer by minus 20. Negatives are fine. What you get?
Negative 0.8.
0.8 amps, yeah? And so by using this formula, I3 is I1 plus I2, so that's I3 is equal to 2 amps. So look what I've done. I've answered this, 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 and finally, in which direction will the electrons flow through the 4 volts?
Why is current negative?
Yeah, but that's important for this one. We got I2 is negative. What's the meaning of a negative current?
It's in the opposite.
The opposite direction. So the current is really going down. So if the current is actually travelling down, which way are the electrons flowing?
Up.
Up. So the answer for part 4 is up. So there's part 1, part 2, part 3, and part 4. Now you see, I like this question because this is like, oh, it's like 10 marks, 10% of the exam.
The other thing is that you have to get all your
Yes,
signs right and stuff.
yes, yes you do.
If you mess up in something, then finding it.
Yeah,
So
it's a 50 versus a
5.
5. So it's like the 50, it's like the 50 forces the car into reverse direction on the right loop.
So through the cell as well.
Yeah, it's been pushed back through the cell.
How does that work out then? Because at the junction, it's
You see, the
only
thing
I1
is,
going in there.
the thing is, Zach, it's alright as long as you're consistent throughout your calculations. You know, it's like if you said the current was going right and you carried out your calculations as if it's going right, and then at the end you get a negative, that's fine. It just means the arrow's pointing the wrong way.
So you would say then I1 equals.
No, don't make any changes retrospectively. Have you written that down?
No, so if you were to do it the other way, so at junction.
Oh, you were
top,
from the beginning,
if
flip
you-
it?
if you
Yeah.
said, like,
Yep.
If you took that junction as like it splits.
Yep.
That way, would it still work out?
If you were saying, if you redid this question but flip the arrow, it'll still work out. But your answer wouldn't be negative. But you'll get an answer of 0.8. Yeah? No?
Seems hard to believe.
No. I invite you to recalculate.
Yeah, I will do it later.
Okay, you wrote that down? Yep. So, here is one I want you to try. Now, wait. I think what we'll do, yes, first I'll have you draw it, and then I'll pick 3 of you to give me 3 equations. Okay, so first draw it, and then I'll ask 3 of you. Okay, you have this drawn? Alright. Who will I pick on? I think I'll pick on Harry. So, Harry, give me any equation. Anyone.
I1 plus I2 minus I3 equals 0.
Perfect. Okay. Did you all write that down? I1 plus I2 minus I3 equals 0. You got that? Who should I pick on next? I'll pick on my buddy Lynn. Okay, Lynn, any equation except Harry's junction one. Where do you want to start?
Try top.
Up the top, okay.
Yeah.
Go for it.
So the battery is
Yep.
7 volts
7, yeah, okay, 7. Next.
and minus 4 and
For what?
4 resistance.
Yeah, but it's minus the voltage. What's the formula for voltage?
Ah,
Yeah,
yeah.
yeah.
For I.
Good, okay, yeah, good. 7 minus 4I1. Keep going. Which way are you going to go? Right or down?
Go right.
Okay.
And plus 5 volt.
Interesting. Minus 5 volts because the battery's the wrong way.
Ah.
You see, you have the plus side with the plus side.
Ah.
Now you should go down. Going down, go this way. It's easier. Yeah. 7 minus 4I1
Minus 6I3.
minus 6I3.
And minus 2I2.
No, actually, this one's not I2. What's this one?
Oh, I3.
No, not I3 either. Is I1. Because look, here's I1, which means here's I1, which means here's I1. Means this whole piece here to here, is I1.
Oh, I2 is for the.
I2 is only from here to here.
Ah.
Yeah.
Okay.
Alright, do you all have that? 7 minus 4I1 minus 6I3 minus 2I1 equals 0.
7 minus 1.
7 minus 4I1 minus 6I3 minus 2I1 equals 0. You got that? Yeah? Okay, Gina. You give me one more.
7 minus 4I1.
Yep.
Minus 5.
Yep.
Is that plus?
Yeah.
Plus 3I2.
Yeah.
Minus 2I1
Yeah.
equals 2.
Perfect. Perfecto. Okay. Let me write those three down. So, Lynn, what was your one?
7 minus 4I1.
Oh, no, sorry. I should do it in order. Harry, what was your one?
I1 plus I2. Minus I3 equals 0.
Okay. Now, Lynn, give me your one. What did you get?
7 minus 4I1.
Yeah.
Minus 6I3 minus 2I1 equals 0.
Okay. Minus 2. I want to try and keep them in order. Sorry. How many I1s do you have?
Oh, yes, 2. So it's minus 4 and minus 6.
Minus 6I1.
Yeah. Minus,
Next, how many I2s?
minus 6I3.
No I2s?
No.
Okay. So it's like plus 0 I2s minus 6 I3s
Yeah.
equals...
0.
No, what did you...
Yeah, equals minus 7.
Minus 7 then on the other side. Yeah. And then who else? Oh, Gina. What was your equation, please? Can you give it to me like this? I1, I2, I3 equal number. What do you get?
So it's minus 4I1
Yeah.
plus 3I2.
Yeah.
Oh, so it's minus 6
Minus 6I1. Okay.
plus 3I2
Yeah.
equals minus 2.
Oh, there's no I3?
Minus 9.
Okay. Equals minus 2 like this. Okay. Now, which do I cancel first? What do I cancel here? I1, I2, I3. What do I cancel first?
7 plus 5.
Huh?
It'll be 7 plus 5.
For the last one?
Yeah, so it'll be minus.
7 plus 5? No! We said 7 minus 5. Because the battery's the wrong way. We're going the wrong way through the battery. It's plus with a plus.
But then the resistor is plus.
Yep, it is.
So, okay. So
Yeah.
if it's a cell, it's minus. If they're in opposite direction.
If they're the wrong way around, yeah. Yeah.
Okay.
What was I saying? Oh yeah, which do we cancel first? I1, I2, I3. I1. So, wait. I just want to make sure you got this. What do we do to the first equation? We should multiply it by minus 6. And then you subtract these two. And then subtract these two to make two more equations. Okay? I'll give you a minute, see if you can solve it. Please all try to get the same answer. Thank you. made a mistake, Lynn.
Yeah, the calculator.
Right, who has an answer? Dorian, you have an answer? You don't look happy about it though. Zach? Okay. Harry? Okay. Gina? You have an answer?
Aye, 3.
Diego?
Getting there.
Did you just get the same answer? Well, let's have a look. So, what's really nice is that, Gina, you have the same calculator as this, don't you? Can I see? Ah, it's nearly the same. Can you type this in? Hang on, let me, wait. Oh, no, hang on, what am I doing? 1 second. Okay, so can you press mode 52? Yeah. Do you get this? Now watch this. 1 equal, 1 equal, minus 1 equal, 0 equal, 6 equal, 0 equal, minus 6 equal, minus 7 equal, minus 6 equal, 3 equal, 0 equal, minus 2 equal, and now the answers. That is I1, 11 over 12, I2, 7 over 6, I3, 25 over 12. Did you get those? Oh, my battery's low. I don't know if that calculator can do it.
Wait, how to get in this
Mode 52 for me, but it might be different for your one.
What do you call that?
Huh?
What do you call that operation?
Simultaneous?
Would be on in algebra or calculus? Algebra.
Algebra for sure.
So the a and x plus b and y plus c and z equals d n.
Is there a way to solve these systems? Gina and Dorian, did you get those answers? You didn't get this?
There you go. So
Look, 1 minus 1 equals 0. Oh, bad teacher. I typed in minus 6, sorry. I made a mistake, sorry. No, your teacher doesn't know how to use a calculator. I wanted... Okay, I'm sorry. I1 is 11 over 24. Did you get this for I1?
Wait, what?
11 over 24.
I typed it in wrong.
1 over 4
1,
and 17 over 24. Is that it? Is that what you got, Gina?
6, 7.
Yeah?
in the exam, can we actually do it?
Oh, this is only for checking the answer.
Oh, like we have to like
Do the
Of course. Now look, before you go, what I want you to do, you have one question in the workbook that's a section A question, and here is one question which is a section B question. So I'm giving you 2 questions to do for homework, the one in the database and this one. Okay? So if you want, you can take a picture of this, or you can just watch the video.
What's the video?
Just you want to take a picture of it? Uh-oh, 50. Dun 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 dun. No, stop.
I like how it blocks. So you can't close the